welcome to lesson 2C-4. We're going to start out with some vocabulary today. We're going to define 3 words in our glossary, so go ahead and turn to our glossary and be ready to fill out these definitions as we go along. Our first word is going to be end behavior. End behavior is the appearance of a graph as it is followed farther and farther in either direction. Our next vocabulary word is one we've talked about before, but we want to go ahead and define it, is an x-intercept. That is the point where the line meets or crosses the x-axis. For our third and final vocabulary word, you might have been able to guess that since we're talking about x-intercept, we're also going to need to talk about the y-intercept, and you would be correct, as that is our third vocabulary word. And the y-intercept is the point where the line meets or crosses the y-axis. So please go ahead and pause your video. Make sure that you have a chance to fill this out in your glossary. When you have all 3 of these words defined in your glossary, we'll go ahead, resume the video, and get started on today's notes. So, in lesson 2C-4, we're going to start talking about some other characteristics of linear functions. Now, so far we've talked about domain and range, and we've talked about slope and rate of change. We're going to combine several other characteristics into one lesson today, kind of kill 2 birds with 1 stone, and instead of spending a day on each one, since they're a little bit smaller and a little bit easier to comprehend and figure out, we're going to go ahead and combine that into one lesson today. So the first one that we're going to talk about is something we've already talked about this semester, and that's intercepts. Remember, the y-intercept is where the graph crosses the y-axis, and its x value is always 0. That's going to become important in our first example, so remember that. The x-intercept is where the graph crosses the x-axis. Now, its y value is always 0. So if you're looking at intercepts, the opposite value is always going to be 0, and that's going to help us out in this example. So we are asked to find the x and y intercepts of this equation 3x plus 4y equals 12. We'll start out finding the x-intercept. The order you do this doesn't really matter, but we'll just go alphabetically. Now remember what I was just saying about the y value for an x-intercept. For an x-intercept, the y value is always going to be 0. So what I can do is I can plug that into my equation to figure out what x is. So I don't know x, so I'm going to leave 3x. But since I know for an x-intercept the y value has to be 0, I'm going to plug that in for y. So that's going to give me 3x, and 4 times 0 is going to give me 0. So I get 3x is equal to 12. So this gives me a simple one-step equation in one variable that I can easily solve. I'm multiplying x times 3, so I need to divide both sides by 3. So I get that x is equal to 4. So my x-intercept, my x value is going to be 4, and remember our y value is 0. Now we're going to do something very similar to find the y-intercept. So to find the y-intercept, remember that x will have to equal 0. So in this problem, we're going to replace the x in the problem with a 0. And we're going to do plus 4y equals 12. This time we have 3 times 0 that's going to go away because it's going to give us 0. And we have 4y is equal to 12. We would divide both sides by 4, and we get y is equal to 3. So if we went and wrote our ordered pair, this time our x value was 0, and our y value would be 3. So that's what you would need to do if you're asked to find the x and y intercept and you're given an equation instead of a graph. If you're doing it from a graph, you can just look and pull it off of that graph. So we can also discuss where a function is increasing and where a function is decreasing. So if the rate of change is positive, we say that the function is increasing. And if it is a continuous linear function, we would say that it is increasing on the interval from negative infinity to positive infinity, or in interval notation, we would write that as negative infinity comma infinity, both in those open brackets, or open parentheses, because we never actually reach either negative infinity or positive infinity. Now, if the rate of change is negative, we say that the function is decreasing. In this case, for linear functions, it will be decreasing on the interval from negative infinity to positive infinity, or we use the same interval notation as before. So our example was to give, are the graphs below increasing or decreasing? So as we can see, our slope in this one is going uphill. So we would say that this function is increasing. Function 2, however, is going downhill if we're going from left to right. So in this case, we would say that it is a decreasing function. Now, eventually we're going to talk about some functions that might be increasing in one place and decreasing in another. But for a linear function, it is always going to be either always increasing or always decreasing. And we'll look at some of those examples in units 4 and 5. All right. So another characteristic that we can use to describe a function is end behavior. End behavior describes what happens to the y value as the x value approaches either infinity or negative infinity. So we're looking at what happens when x gets really, really large and positive, or when it gets really, really large and negative. All right, so this is the format that we typically write end behavior as, right in here. We typically have these two sets of lines, and we would say as x approaches negative infinity, y approaches, and then we would have to fill in the blank. And just as I read it out loud, these symbols translate to x approaches negative infinity, y approaches what? All right, we also have to do a second part for end behavior. As x approaches positive infinity, y approaches, and then we have to figure that out. So in each case for end behavior, we should have two different answers because we have two different scenarios. One where the x value is going far to the left towards negative infinity, and one where it's going to the far right for positive infinity. And that I'm realizing now that on the camera that's probably opposite, but in my way I'm going right and left. All right, so we want to describe the end behavior of the functions below. So we're always going to start out as x, and then we're going to draw that arrow, approaches negative infinity. Y approaches. So we're going to look at this graph, and sometimes what I find is helpful is to have a little line to help guide you, kind of like when we did the vertical line test. Now, as x approaches negative infinity, that is moving in that direction. So I'm going to drag my line that direction. Now I'm looking at my graph, and I'm going to try and tell where y is going. So as I go further and further left, my y value is decreasing and decreasing and decreasing. It's going further and further downhill. So since this is a line that goes on forever, it's going to keep on going and going and going. So we would say, since this is going down in the negative direction, that y would approach negative infinity. All right, we also have to do as x approaches positive infinity, y would approach. And this time we're moving in the opposite direction. We're moving to the right because positive moves this direction. So in this case, the y value is continuing to go up higher and higher and higher. So we would say that y would approach positive infinity this time. All right, let's jump over and look at our second example. In this case, we're going to look again as x approaches negative infinity, what y is doing. So in this case, if we take our line and we move in the negative x direction, this time we're going to see that y is continuing to go up higher and higher and higher. And since this is a linear function and we have an arrow at the end, it's going to go on forever. So this time y is getting really, really large, but positive. So we would say that y is approaching positive infinity. Now as we do as x approaches positive infinity, and we move in the positive direction for x, this time as we drag our line and we move as x is positive, we're going further and further downhill, and that's going to continue going on forever. So this time our y is going down, and it's going down forever. So we would say that y would be approaching negative infinity. One more example that I want to go over with you guys for end behavior. For end behavior, sometimes you might see a function where it's restricted, where it stops here. In this case, when we look at it, as x approaches negative infinity, we're going to keep going down, and our y value is going to go down and become more and more negative. So we would say y approaches negative infinity as well. But notice this time, as x approaches positive infinity, if we get that line back out here, and we move from left to right, since we have a dot instead of a line, everything's going to stop right here. So as x continues to go out towards infinity, our line has stopped completely. It doesn't go any further. So our y is actually going to stop as well. So as x continues, our y value doesn't. So what we would say here is that as x approaches infinity, we would say that the end behavior for y does not exist because it simply just stopped in its tracks. All right, and a way that you guys can abbreviate that is D and E. All right, end behavior is probably the most confusing of these characteristics just because it's a totally abstract way of thinking things. So if you need help or have any questions, feel free to pause the video and ask for some further explanation from your teacher. So I'll give you guys a minute to pause it, recollect your thoughts on that, and then we'll move on into the next segment of the video. All right, our last characteristic is going to look at where on the graph the function has a positive y value and where it has a negative y value. And we can either use set notation or interval notation to describe the intervals of positive and negative. Since I'm an optimist, I'm going to go ahead and start in this example with the positive interval. So we are going to look at where on the graph the y value is positive. So the key thing that we're going to look at here is where our x-intercept is. So right here is going to be where x-intercept is. Everything that's above that is going to be positive, and everything below that's going to be negative. All right. Now, at the point 0, where y is 0, it is neither positive or negative. It's neutral. So we're going to start out at the value -1. That's our x value where it starts going up and being positive. Now, as we just said, since y is 0 there, it's not positive or negative, so we are going to just use the less than symbol as opposed to the less than or greater than symbol, or less than or equal to symbol. Now we're talking about x, all right? Now, if we go positive, it's going to keep going up here forever and ever. So our value, as x goes further and further out this way, is going to be infinity. And just like we've talked about before, we can't actually reach infinity, so we can't put the bar underneath there to say equal to. Now, if we wanted to write this in interval notation, we would use open parentheses, since both of them have the points not included, and we would write the same two boundaries. Now for negative, it's going to be everything below the y-axis. So in this case, it starts out from the very beginning as negative. So it's going to start out at negative infinity because that's going to keep going further and further left. It's not going to turn around on us. All right. And as far as where it stops being negative, that's where that intercept is. Again, remember, since at -1, the y value would be 0. It's neither positive nor negative, so we can't include that, so we have to have the less than symbol, but we would say that it is less than -1. If we were writing it in interval notation, we would do negative infinity with a parenthesis to -1, again with a parenthesis. All right, so that wraps up intervals of positive and negative. This is probably one of the easier characteristics. Again, you're just looking at what x values the graph is above the line and what x values the graph is below the y-axis, or sorry, x-axis. So that wraps up our other characteristics. Go ahead and pick up application 2C-4 from the Algebra Embassy. Remember, your application video can be found directly below this video on the Great Math Adventure. As always, let your teacher know if you need any help, and we'll see you in the next lesson, the last lesson for 2C- or for the Unit 2C. All right, see you guys there.